So next we will discuss about memory leaks. What are memory leaks? Memory leaks occur when you allocate memory using the new keyword, but you forget to deallocate using the delete operator. Okay, so we have already seen multiple examples of using new along with the delete, and here we will discuss another example which is related to functions. So here we have a function void my function, and inside this function we have this statement which is using this new keyword. So what it is doing, it is reserving memory equal to the size of an integer. Suppose the integer occupies 4 bytes, so 4 bytes will be reserved in the memory. Okay, and these 4 bytes will have an address. The base address the base address will be the starting address, that is the address of the first byte. Then suppose these are the addresses of all the 4 bytes. Okay, so what the new operator will do, the new operator will allocate memory equal to the size of an integer, that is 4 bytes, and it will return the base address. So the new operator will return the base address, that is 1000 in this example, and it will be held by a pointer variable int star data. So this address will be stored here. Okay, and then star data is equal to 50. It means we are putting a value 50 in this memory location. Okay, so 50 is being stored here. Okay, so now this is a local variable. This pointer variable is a local variable to this function. Okay, so suppose this is the main function here, int main, and in the main function you call my function. Okay, so what will happen with this? The control will go to this function, and what this function will do, it will create a pointer variable data, and that pointer variable will point to some memory. This memory is not a part of this function. The part of this function is only this pointer variable. Okay, so this function contains only this pointer variable data. So this is the function my function, and it is having a data member which is pointing to some memory which is outside this function. Okay, and when this function completes its execution, it will return to the main function. Okay, so what will happen then? All the local variables which were created by this function will be destroyed. So this data will be destroyed. Okay, when this function becomes out of scope, when this function terminates, all the memory occupied by this function will be released automatically. So this data, this will be released automatically. But this memory which this data was pointing to, it will not be released. It will stay there in the memory. Okay, and suppose again you call my function. Again the control will go here. This my function will be executed. It will create a data pointer. It will point to another memory location equal to 4 bytes, and when this function will terminate, this pointer will be destroyed automatically, but this memory will not be released. And if you call it again and again, 4 bytes of memory will always be allocated but never be deallocated. It will result in the memory repeatedly being allocated but never being freed. So ultimately you will run out of the memory if you run this my function multiple number of times. Okay, and uh, at the end your system might crash because it will run out of the memory. So therefore it is very important to release whatever memory you are occupying using the new operator. You must release that memory using the delete operator. So the correct format of this function should be, at the end we should write a delete statement, delete, and uh, here we will write data. Okay, so now what will happen before this function terminates? It will release this integer which has been occupied, and then it will destroy all the data occupied by this function itself, and then only it will return. Okay, so every time you call this function, all the memory occupied by that new operator will be released by delete operator, so there will be no memory leaks. Okay, and the situation can become even worse than this. This is only occupying only one integer, that is 4 bytes. But imagine if instead of an integer you have an array, and uh, that too of suppose 100 elements, then the situation can even become even more worse. Okay, so therefore it is very important to avoid these memory leaks by using the delete operator along with the new operator. Okay, and then we have the topic of allocation failures. We have already seen the allocation failures. Allocation failures occur when you try to dynamically allocate memory using the new operator, but the program crashes when the memory is not available, or the system is not able to allocate memory to a program. Okay, so the program crashes abruptly if the memory is not available, but you can handle that crash gracefully using an exception handler or using the no throw version of new. Okay, so to prevent the program to crash, we need to handle the exception when the memory allocation fails, and there are two techniques: using the try catch block, which handles this allocation exception, bad allocation exception particularly, and the second option is using the no throw version of new operator, new then parenthesis no throw. Okay, and at the end these are the references for this chapter.